Is a derivative graph question. So it's testing your understanding of how graphs change when you get the derivative of a function. So let's look at this first part. So each diagram below shows the graph of a function. Each is one of these: quadratic, cubic, trigonometric, or exponential, not necessarily in that order. So the question here is to complete the table below by matching the functions to its first derivative and its second derivative. So they gave us this. They gave us this table, and we have to fill it in. So first off, which of these is a quadratic? The smiley face is a quadratic, or alternatively it could be like that. That would also be a quadratic, but it's not. So K is a quadratic. Which is the cubic? So cubic means it has 3 roots, so it touches the x-axis 3 times. So 1, 2, 3. That's the cubic. Which is the trigonometric? You could argue it looks similar to the cubic, but trigonometric is very regular. You see, it's very regular shape, and it goes on forever, both directions. And we can see that's about to touch it up here. So 1, 2, 3, 4. And it starts at the origin. So this is a sine wave, actually. It starts at the origin, goes up and down. Whereas this is a little less regular, and we can see it's not going to touch it again. And anything that zooms up in either direction is an exponential. So that's h. The next part of the question is to label the first derivative. Okay, so using the trick, the dashed line trick, you could go to this maximum point and draw a line down. To this minimum point and draw a line down. And for anything that is a derivative of this, it should touch the x-axis at these points, because the derivative is 0 at these turning points. Okay, so let's see, does any of them touch the x-axis of those 2 points? So this one is further to the left and further to right, so not this one. This one only touches it once. This one never touches it, comes closer to it. This one touches it close to the y-axis and further away, so it's this one. The other way of telling is that a cubic function, the derivative of it is always a quadratic function, because you're subtracting 1 from the power. So this matches with this. Okay, so the first derivative of that the first derivative of f will be d. This is a trigonometric function. Trigonometric functions always derive to trigonometric functions. So if we look at the table here, cosine goes to sine, sine goes to cosine, and so on. Okay, so you can't escape that loop. So this is going to go to another trigonometric. This is a sine one. Okay, get rid of these. An exponential always goes to an exponential. See here, ex, ex. Even if you have a coefficient to the x, it's still an exponential. It might be the other way around or inverted or something, but it's still an exponential. It's zooming off in some direction. And a quadratic, again, you think you're decreasing the power, will go to a line. The other way of looking at it is if you were to draw a line down from that maximum point, and it would hit the x-axis just after in this positive zone here, which it does. It's not exactly to scale, but that's the other way of testing it. You can also see that when this slope is negative, when it's going down, this is in the negative zone below the x-axis, and when it's positive again, it goes above the x-axis. So differentiating again, you can't escape the loop of a trigonometric equation. It's going to differentiate to a trig equation again, although it's going to be minus sine x this time. As you can see here, cosine x goes to minus sine x. Now, a line always differentiates to a constant, because it's just something like 2x, you'll be left with 2, for example. So a constant looks like a horizontal line on a graph, because you can imagine if that was 5, it would stay at 5. It's always 5. no matter what. Exponential, can't escape the loop of an exponential. Quadratic, same way as a quadratic went to a line before, quadratic goes to a line. Okay, so you just fill in the blanks here. I ask you to explain for one row, not for all of them, for one. One simple way would be to say a quadratic differentiates to a line, which differentiates to a constant.